This is FP3 January 2007, question 3, a complex number question. I've got that zoomed in on the board here. It says, solve the equation z squared minus 6z plus 36 equals 0, and give your answers in the form r cos theta plus I sin theta, where r is greater than 0 and theta lies between 0 and pi. And then it's going on to say, given that z is either of the roots found in part I, deduce the exact value of z to the minus 3. Okay, let's do that. Now, we're going to start with using the traditional formula. I know we've got a complex variable here, but this should work anyway. So, we've got z squared minus 6z plus 36 equals 0. Now, put that into the formula. Z equals 6 plus or minus root 36 minus 144 all over 2. Simplify that down a bit and we're going to get 3 plus or minus root minus 108 all over 2, which is 3, sorry, getting ahead of myself there. That's 3 plus or minus. Now this one simplifies down to root 27i. 3 plus or minus root 27i. Now at this point, let's draw ourselves a little diagram. Get our head around what this looks like. So our point's going to be there. We've got root 27 on the imaginary axis, 3 on horizontal. We're going to want the argument there, theta, and the modulus, the length of that r up there. Now, that r is going to equal, by Pythagoras, root of 27 plus 9, which is root 36, which is 6, reassuringly whole number there. Now, the argument, theta, is going to equal 10 to the minus 1 of root 27 over 3. Now that simplifies down to 10 to the minus 1 of square root of 27 over 9, which equals 10 to the minus 1 of root 3. Now 10 to the minus 1 root 3 is in one of our favourite triangles. It's in 1, 2, root 3, and the angle down there is pi by 3, which means that theta equals pi by 3, which then means we can actually write out our answers as they wanted, as z is equal to 6 into cos pi by 3, and then the two roots are given as plus and minus I sine pi by 3. Complex conjugate pairs, as we'd expect. And that's the first part of that question done. Now, second part of that question said, I'll turn over, second part of the question said that if this capital Z they've got is either of the roots, so Z is either root. Interesting that they said that, but we'll see why in a minute. Find z to the minus 3, and they said the exact value, so we're expecting this to work out quite tidily. Now, let's remind ourselves on this side of the page what z is equal to. So that's 6, and I think we'll go with the one in quadrant 1, so we'll have z equals 6 cos pi by 3 plus I sine pi by 3. Now, z to the minus 3 is going to be 1 over z cubed. So z to the minus 3 is going to be 1 over 216, 1 over 6 cubed, then times 1 over, now the cube of this complex number here, the cube of cos pi by 3 plus I sine pi by 3, is cos pi plus I sine pi. Cube it, we simply multiply the argument by 3. Now, 1 over a complex number means, and if we have a quick sketch, means effectively we subtract the arguments. It's the argument of 1, which is 0, minus the argument of this one, which was pi here. So if we think about the fact that z cubed is up there, down here is z to the minus 3. So our actual z to the minus 3 is going to be 1 over 216 cos of minus pi plus I sine minus pi. That's z to the minus 3 at the moment, but it's not quite as exact. When they talk about finding the exact value, it might be right, but notice that pi is a nice whole number, and we know what cos minus pi is, because remember the argument here, minus pi is, well, the angle pi, the argument plus pi that way, minus pi this way. So cos of minus pi plus I sine minus pi is a number on the negative real axis. So in fact, and the argument here is minus 1 over 216. So the final answer z to the minus 3 is simply minus 1 over 216, because that argument minus pi takes us all the way around to the negative real axis. And that is the end of question 3.